Hey guys, I'm Tony, and today I'm going to be showing you lots of things with triangles, such as finding angle measurement, finding side lengths, and similarity and congruence postulates. The first thing I'm going to be telling you about is how to find angle measurement in right triangles. So for this, you will use sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And an easy way to remember this is SOHCAHTOA. Usually when you get your triangle, you're going to label like the sides, and you're going to label it opposite, adjacent, and hypotenuse, depending on where the angle labeled is at. Okay, so here you have a triangle, and it has the angle of 40, and it has the sides 4 and x. So first you have to figure out which sides are hypotenuse, opposite, and adjacent. So what I'm going to do is I'm going to take a different color marker, and I'm going to label the sides. So the hypotenuse is always the angle that's across from the right angle, so that's obviously the hypotenuse. And the opposite is the one that's opposite of the angle, so this is the opposite. And this is adjacent. So since you now know that, you can now figure out which system or whatever you call it to use, like cosine, sine, or tangent. And since you have the adjacent and hypotenuse, you are going to use cosine for this, which is also known as cos. And that equals adjacent over hypotenuse. So what you're going to do is you're going to take cosine of 40 equals x over 4. So to figure out that problem, you're going to multiply both sides by 4. And then, so that would be, and the 4's and this one cancel out. So then you'll get your calculator over here. You'll get your calculator. Okay, so for this one, you are first going to label the sides, and I'm going to get another pen to do that with. So obviously this is the hypotenuse because it's across from the right angle. This is opposite because it's opposite of the angle that is labeled, and this is the adjacent. So since you have opposite and hypotenuse, you're looking for the sine of this, which is equal to opposite over hypotenuse. So you're going to do sine of 63 equals 10 over x. So you divide both sides by 10. You're going to put 10 divided by sine of 63. Enter. To find side lengths, you're going to use similar to the thing that you used for angle measurements. You still use sine, cosine, and tangent, but instead of typing into your calculator sine, you're going to type in sine -1. And instead of using the side lengths when you're plugging them in, you use the angle measurements. Another way to find side length in right triangles is Pythagorean theorem. Pythagorean theorem is like a squared plus b squared equals c squared. So that means like the first side squared plus the second side squared equals the third side squared. Next, we're going to talk about similarity and congruence in triangles. And similarity and congruence is for any type of triangle. It doesn't have to be a right triangle or an acute triangle or an obtuse triangle. It could just be any kind of triangle. Similarity is when the triangles have usually they have the same angle measurements but different side lengths. And some of those postulates are angle, angle, and when you have angle, angle, the third angle is always the same because if you have two angle lengths, you always have a third. Side, 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 and side angle side. And for congruence, there is angle angle side, side angle side, and side side side. And also, if the triangle is a right triangle, you can have hypotenuse leg. And as you can tell, some of these postulates were repeated for similarity and congruence. Usually, if an angle is congruent, it's also similar because they have to have the same angle measurements to be the same triangle. Well, hopefully you learned how to do these things. Make sure to practice a couple of these before you try it out for anything. And, yeah, thanks for watching. Bye!